Hello, welcome to our second Greener Talk organized by AXIA Innovation in the context of the Horizon 2020 Greener Project. I'm happy to have with me Dr. Mirella Di Lorenzo from University of Bath, one of the Greener Project partners. Mirella is a reader in the Department of Chemical Engineering of University of Bath. Hello, Mirella. Would you like to say a few words as well?
Yes, so as you said, I work at University of Bath in the Department of Chemical Engineering, and my research expertise is in bioelectrochemical systems. And part of the Greener team is also Professor Barbara Kaspritz-Horden, and she's from the Department of Chemistry. And her research expertise is in analytical chemistry.
Let me start with the first question about your opinion on how Greener can contribute to the European Union's bioremediation technologies development.
So the idea of Greener is to combine together different strategies for the bioremediation of water and soil. So it is about trying to find the right way of integrating different approaches that are cost effective, but they're also green, as the name of the project suggests. So solutions that actually don't require or require a very minimal use of fossil fuels, and that in some cases actually are self-powered, so don't require any external power input to function.
Mm-hmm. Thank you, Mirella. Could you now give us more information about the involvement of University of Bath in the Greener Project?
So the University of Bath is involved in the bioremediation of soil only. So we work on the development of technologies that actually can advance the biodegradation of pollutants and specifically pesticides and hydrocarbons in soil via the use of bioelectrochemical systems. In particular, we work with the so-called soil microbial fuel cell technology. As you can see from this slide, it's a very simple technology that consists of two electrodes, an anode electrode and a cathode electrode. The anode is buried in the soil and the cathode is exposed to air. And basically, the system takes advantage of microorganisms that are naturally present in the soil to degrade, to oxidize pollutants in the soil. And via this process, electrons are also generated that are actually transferred via an external wire to the cathode, so electricity is also generated. So just to summarize, the technology oxidized via the action of endogenous organism, endogenous bacteria, the organic pollutant, but at the same time it generates a useful electrical energy. So a self-powered treatment of pollutant in soil. We have been working, as I said before, on the degradation of pesticides and on the degradation of hydrocarbons, so recalcitrant pollutants.
Great. This sounds like an excellent research work and well done. And I would now like to move to the last question. If you could provide more insights on the progress that you have already made during the Greener Project implementation.
Yes, if you could go back to the previous slide, please. We are actually tackling the problem with different approaches. So first of all, our focus was to develop innovative designs for the soil microbial fuel cell technology, and we've been doing this in collaboration with the University of Cagliari in Italy, that it's helping us with mathematical simulations of the process, and it's guiding on the development of innovative designs, but also with the collaboration of LATAT, also in the Greener project, that is providing us with cost-effective electrode materials. Then we have performed test in controlled conditions. And by controlled condition, I mean control of temperature, control of irradiation, and irrigation conditions as well. And we have performed tests in the presence of different types of pollutants. But the other thing, and this is the collaboration with my colleague here at Bath, Professor Casper Horden from the Department of Chemistry, we are also doing actually an investigation of degradation pathways occurring in the soil with and without the use of the soil microbial fuel cell technology. And this is done with advanced HPLC methods coupled with mass spectrometry.
Thank you. And yeah, I can see the collaboration among the greener partners and all the work that you have been doing in the field of bioremediation. So I would like to thank you very much for your time and for this talk. And see you soon. Bye.
Thank you. Thank you. Bye, everyone.
Bye.
Bye.